All right, so tonight we have 4 really awesome presentations. We have the 3 Norman teams who will be presenting, as well as our Tulsa team. They have driven down here from Tulsa to give us a short pitch and tell us about what they've been working on this semester. But for each of the presentations, I want to invite the team leader to come up and introduce their team. The role of the team leader is very important to CCEW. These are students who have distinguished themselves as interns in the program, and this group is really no different than any other group we've had. So our first one is Samantha Wong. Samantha is the team leader for the Radar Team, and she set herself apart as an intern by just the sheer intellect that she has. She speaks how many different languages? 5 different languages, so you can test her on that later. But what was really interesting is when we were in team leader training, we were talking about how to deal with stress, because sometimes, managing a group of your peers can be rather stressful. You've been given this big problem. And she said, I don't get stressed, I just do. And so if you ever have the chance to look at Samantha's resume, you will see that she does indeed do a lot. And I am really looking forward to see where this young lady goes. She's incredibly talented. She's a positive force and a motivator in her team, and you'll be able to see that in their presentation tonight. But I will let her introduce them, and we will start with our presentations.
Thank you, Val. So, first, there are specific people I would like to thank. Firstly, is the researcher in the Advanced Radar Research Center who has been patiently helping our team to understand the radar technology. And we would also like to thank the EEC, especially Mr. Andrew Israel, as well as his team of executives in showing their trust and support for our team. And last but not least, we would like to thank specifically for the CCEW staff who had been tremendously supportive in any way possible for the semester. And without them, this project won't be possible. And as far as the team goes, I think it has been a real pleasure to work with them this semester. And for our team, we have a very interesting slogan that I will share with you all, which is whatever it takes to make this goal happen. And of course, it has to be legal and ethical. And, but I do think this slogan gives a good representation of the team, because these 4 interns, they are incredibly driven, they are very intelligent, and they have continued to show their dedication and their capability in delivering quality work, as well as their interaction with different companies, executives, and representatives. And I must say that I'm really impressed by the high level of professionalism and also ability they have demonstrated. But I would say that this team is not only a work team. We are friends and possibly, namely, the family of the semester, because we have spent so much time together. There are weeks that we see each other every day, and we won't get sick of each other. We'll still get breakfast at egg in the morning, and we do drink tea, and we eat homemade pumpkin pies. So it is very lucky to get to know them all, because I know that this friendship will extend way beyond this semester. So, ladies and gentlemen, I would like to proudly present Team Radar, and I'm really excited about the presentation they are going to offer to you all. Thank you.
Oil and weather detection are 2 major industries that have a huge impact on the state of Oklahoma. The OU-developed technology we'll share with you tonight will link these 2 industries together like never before, bringing wealth to the state and creating long-lasting impact on new markets. Hello, my name is Andrew Belliveau, and I'm a senior studying economics and international business from Columbia, Maryland.
I'm Sam Parrill. I'm a junior studying aerospace engineering from Garland, Texas.
Hello, my name is Allie Kallmann. I'm a mathematics and letters senior from Franklin, Wisconsin.
And I'm Julie Bock, a junior industrial engineering major from Edmond, Oklahoma.
We have been working with our inventor, Robert Palmer, our mentor, Mackenzie Britt, and our team leader, Samantha Wong, and we are Team Radar. Our goal for this semester has been to find the best possible market for novel weather radar called the Ranger, created right here at OU. The Ranger was created by Enterprise Electronics Corporation, or EEC, a global weather radar company, in conjunction with the Advanced Radar Research Center, ARRC, here at OU. Traditional radar was limited to use by national weather services and news stations. But the Ranger's innovations in technology make it smaller and more cost-effective, opening up the possibilities to expand into new markets and serve new customers. After extensive market research, our team selected offshore oil platforms in the Gulf of Mexico as the best possible non-traditional market because offshore oil platforms are vulnerable to the intense winds in the Gulf of Mexico. Specifically, weather affects oil companies in two ways. It inhibits their operational efficiency and it endangers the safety of their workers. First, let's focus on their operational efficiency. Helicopters transport oil workers back and forth between the mainland and offshore oil platforms, as well as deliver food, water, and supplies. Essentially, they are the lifelines for offshore oil platforms. Helicopters take more than 365 regular trips out to oil platforms every single year. This adds up to a total cost of $2.9 million per platform, or at the macro level, $278 million. However, our team estimates a cost that is wasted of $36 million. But where do these cost inefficiencies arrive? Whenever a helicopter takes a regular trip out to a platform but cannot land due to unpredicted wind shear, they are frequently forced to return to the mainland or taxi until it is safe for them to land. Wind shear is basically sudden gusts of wind which are especially prevalent in the Gulf Coast and are very dangerous for helicopters. Fully 10 to 12% of all of these helicopter trips are wasted simply due to wind shear. It's not just about the cost savings of $36 million that we can offer oil companies, however. It's also about the safety of the workers on these helicopters. Helicopters are prone to dangerous crashes in the Gulf. Of the 5 crashes that are likely to occur in the Gulf next year, 1 will be due to weather. They are very expensive and cost $20 to $40 million per crash. However, more important than that, they endanger the lives of the 18 workers on the average helicopter trip. In our conversations with oil executives, they have told us keeping our workers safe and saving lives is worth any cost. In fact, the average platform spends $10.4 million on worker safety. So we know that oil companies have not only the budget, but also the need to purchase the Ranger. In fact, BP looked into platform-based radar a few years ago. However, they were blocked from placing radar on their platforms for several reasons. First, the traditional radar was too large and could not fit easily onto platforms. Secondly, the powerful radar waves in close proximity were actually dangerous for workers. And third, the radar was ineffective at predicting wind shear. Now, Sam will tell you how our radar, the Ranger, overcomes these problems to save lives and assets in the Gulf of Mexico.
Thank you, Andrew. The Ranger will give oil platforms the ability to see and predict weather conditions to prevent the loss of life and assets in the Gulf. The Ranger enables this weather prediction by supplying detailed data and a clear picture that gives the helicopter pilots and navigators information that they can use to save helicopter trips where the helicopters would be unable to land due to the heavy weather. It will also help them prevent helicopter crashes, which can be extremely expensive or even fatal. The Ranger overcomes the obstacles that formerly existed in this market to providing this very important radar coverage. Especially in comparison to traditional radar, this radar is very small and compact. It is less than 5 feet tall, 3 feet wide, and weighs less than 400 pounds. It is also very energy efficient, using less electricity than a standard blow dryer. Because of its small size and ability to perform without a radome, which is the large dome you see outside most radar units, this radar is able to be placed with a great amount of flexibility on the offshore platform. It is also much safer for workers. The energy emitted from this radar is very comparable to what you'd experience whenever you use your cell phone. Because of these innovations, this radar is ideal for offshore platforms. However, these capabilities would not be possible without 2 key technological innovations. These 2 innovations are pulse compression and dual polarization. Dual polarization is crucial for detecting weather in the Gulf of Mexico. Traditional radar sends out only horizontal waves. This radar sends out both horizontal and vertical waves, adding another dimension to the radar prediction. This allows them to gather twice the data, and it also allows them to see into and past obstructing weather conditions like heavy rain that would normally block a radar signal. Most importantly, however, it allows the radar to detect wind shear, which is the most dangerous condition for helicopters in the Gulf of Mexico. Pulse compression is what turns this radar from a small, low-energy X-band radar to a high-power tool for detecting the weather. How this works is it takes a low-energy input, which allows it to be very energy efficient as well as safe for workers, and turns that, through advanced signal processing, into a high-power output, which results in a high-range resolution. Detecting the same weather at the same time, you can see that the picture with the higher range resolution is much more clear and easier to use to determine the weather. This is the kind of picture that our radar would provide. Because of these innovations, this radar can be applied to many different markets. Now, Allie will talk to you about the specific market that we've chosen for sales of the Ranger.
Thank you so much, Sam. We have selected deepwater oil platforms in the Gulf of Mexico as the target market for the Ranger. This market is worth $26 million. We selected this market for 3 key reasons. First, because of the unique weather patterns in the Gulf. Second, because of the limited radar data on deepwater platforms. And third, because of the frequent helicopter trips they have to take out to these platforms. First, the Gulf of Mexico has unique weather patterns, especially wind shear. This makes it extremely important to be able to predict the weather as clearly as possible. Second, there are 2 types of platforms in the Gulf of Mexico. Shallow water platforms are located on the continental shelf and much closer to shore, so they are able to use onshore radar data to make their daily predictions. Deep water platforms, on the other hand, are located much further from the shore and can't use that same onshore prediction. They also use frequent helicopter trips. Daily, they rely on these helicopters to bring them the workers and supplies they need to be operational. There are over 95 of these platforms manned in the Gulf, in the deepwater section of the Gulf, and over $1 billion is spent on the safety of these workers every single year. Within the deepwater platform market, there are 2 types of customers. First, larger companies have a higher presence in deepwater because of the high barriers to entry. We recommend that EEC work with each of these companies individually to create an internal radar network. For example, BP, which has 10 deepwater platforms, would be able to use 6 Rangers in order to provide full and accurate coverage. Smaller companies, on the other hand, are just starting to get into deep water, and most have only a handful of platforms. This gives them a strong incentive to protect these investments, but they won't be able to create a radar network like with the larger companies. For example, W&T Offshore has 6 deepwater platforms and would need to get 4 Rangers to provide full coverage like BP. It is clear to see that deepwater platforms in the Gulf of Mexico can stand to benefit from improved weather prediction. Now let's take a look at how EEC's Ranger compares to competitors in the market. We will first look at EWR's E700XD, a similar lightweight X-band radar that has been placed on offshore platforms off the coast of Africa. The second is the gold standard used by the National Weather Service, the WSR-88D. This is a traditional radar unit. Finally, we'll look at how EEC's Ranger stacks up against these 2 competitors in categories that are crucial for success in the deepwater platform market. First, pulse compression is what transforms potentially dangerous radar waves into smaller waves that are safer for workers. Both EWR and EEC use this technology, making them able to be placed on platforms. Repair work is dangerous and difficult in these remote locations, which means that it's important that a radar unit can go for a long time with no maintenance. Both EWR and the National Weather Service units would need replacement parts within the first 6 months, whereas EEC's Ranger can go a full 10 years with absolutely no maintenance. In order to be successful at predicting the weather on these deepwater platforms, a radar needs a range of at least 80 kilometers, which all of these radars exceed. Traditional radar units can cost upwards of $2.5 million, like the WSR-88D. We recommend that EEC set the cost for the Ranger at $650,000, which is significantly more cost-effective than a traditional radar unit. Now, EWRs is slightly less expensive, but this is because they lack dual polarization, the key innovation for making a radar successful at detecting wind shear. Without it, EWR is potentially endangering these helicopter lifelines. Because EEC uses dual polarization, they are an ideal choice for detecting weather in the Gulf of Mexico. Now, Julie will explain how we recommend that EEC bring the Ranger to the deepwater offshore oil platform market in the Gulf of Mexico.
Thank you, Allie. OU and EEC have been working to establish a licensing agreement that will allow EEC to sell the Ranger. The cost that they will incur for one of these units is between $275,000 to $325,000. This includes the cost of radar parts, of the very specialized labor, as well as the cost of marketing and sales. EEC will need to contact the meteorology departments within these companies. They will have the power to make the purchasing decision for this unit. For companies without meteorology departments, EEC will need to contact the operations department. We have suggested that EEC price this unit at $650,000. This is based on a 2-year return of investment for these platforms. There's a $12,000 per year software fee that will be absolutely essential for the workings of this radar. EEC will have an added cost of 5 to 15% that will go back to the university in the form of royalties. For this cost, or for this price, we have estimated it at $65,000 per unit. This will give EEC a total cost of $300,000 to $350,000 for every unit sold. Once we put these projections into the next 4 years, we see that EEC will incur a cost of $2.8 million, which is just the first year for this market. This will include the cost of training this very specialized labor to work on the manufacturing equipment that this type of product demands. In addition, they will have to buy a new facility as they will be doubling their production with this unit in the first few years. We suggest that EEC sells 3, 5, 9, and 13 units in the first 4 years respectively in order to break even in 2014 as well as to reach 30% market share within the first 4 years. This will give EEC a total profit of $8.1 million in these 4 years alone and will have a great benefits for OU as well. In the form of royalties, OU will get about $1.9 million, which is assuming 10% royalty rate. As you can see, this is a very profitable venture for both EEC and OU, and here's what we suggest EEC does to implement this strategy. First, they will need to approach the major players within the offshore deepwater industry. They will have the large budgets that will be able to incur a large capital investment, so they will be able to begin selling in the first year. In addition, they will need to also begin building relationships with smaller companies. With the scale of these smaller companies' budgets, they will not be able to incur a large capital investment in the first year. However, by developing these relationships, they can then put it into their budgets for future fiscal years. EEC also needs to look to expand the market. They can put radar, or they can sell to companies with platforms that are closer to shore in the same Gulf of Mexico. Also, they can look to selling to these same companies international counterparts, as many of these companies have platforms around the world. In addition, they can look into other non-traditional markets for this same radar. Some of these could be government-funded agencies, airports, and other non-traditional markets. We have really enjoyed working with both EEC and OU, this Advanced Radar Research Center, with this project. They have been very, very helpful with our research. We have also had great help from people across the industry, from everything from offshore platform workers to international operators of airports. We look forward to seeing how EEC implements this strategy to save lives and assets in the Gulf of Mexico and to bring economic wealth back to the university as well as the entire state of Oklahoma. We would like to open up the floor for questions at this time. Thank you.
Yes.
This technology is readily available. Well, it's not readily available, but it's available to the market right now. But the unique configuration of the radar with all the components is what makes the radar more exceptional. Does that answer your question? The pulse compression, as well as the dual polarization and the solid state amplifier, which I didn't mention, that's included in the radar, and the actual construction of the radar. It's made to be very durable and to have all these parts working together in the best way.
Yes.
Another way of asking the same question is this a proprietary and patented process that we're trying to sell here?
Sure. So the question was in regards to the intellectual property status of this. I'll actually step from behind the podium so you all can see me. Currently, both EEC and OU's Office of Technology Development, OTD, are looking into the patentability of certain aspects of this radar. Because it does not have any patent, we don't have a patent at this time. That's part of the recommendation that we have to move so quickly in this market. But we believe that this radar is really innovative and has definite patentable aspects.
Yes.
In looking at potential markets, you focused on the transportation of oil workers and supplies.
Mm-hmm.
Did you look at the cost of downtime, say, due to tropical storms, and what impact the radar could have on that?
Yes, we definitely saw that as a big benefit, that we can offer a better picture for the oil companies, especially in the case of hurricanes. Mm-hmm. But for the most part, oil companies already know when there's going to be a hurricane headed their way. And in that case, that's really the only scenario where they would shut down their entire platform and everything. So it would save them a lot of money, but they already have land-based radar that pretty much solves that problem. So the biggest value added that we can give them is through their helicopters and by adding safety for their workers. So, yes.
Do you need a Troy Christensen to read these, or can anyone read these?
There's actually a person on every platform that currently gets data and predicts weather based on various services that these kind of platforms subscribe to. So they already have someone on each platform that can interpret this type of data. So they would be the one that would be trained by EEC to interpret the radar data from this specific ranger.
Yes, up there.
I'm curious, how often do companies tend to replace the radar equipment that's used on their platforms? And then with that, the 30% market share that you anticipated getting in 4 years, is that from machines that you would expect them to replace anyway, or are you asking companies to go and switch before they might otherwise do so?
Mm-hmm. Right now, no oil platforms currently have radar on their platforms, simply because of those problems that I discussed. They were too large. It was actually dangerous for the workers. So that's what's really special about this new product that EEC and ARRC are working together on, is that they can be placed on platforms where they weren't able to go before. So we're hoping to capture 30% of this market that is completely untapped. So.
Is this radar one that can scan 360 degrees, or would one platform need multiple radars to provide the coverage, adequate coverage?
This radar can give a 360-degree coverage, given that it's in the right position on the oil platform, and because of its size and its ability to go without a radome, it will be able to detect 360 degrees.
I have time for one more question.
Yes.
When you did your proposal for your startup costs, why did you elect to purchase the building or construct the building as opposed to leasing the existing facility?
This is one of the things that we've talked with EEC about, and this is how they have their current practice at their facility in Alabama, so we thought that it was best to implement this same practice for their new facility.
So are there unique properties for the building, for the construction on these that one? I was just curious as to how you came up with that. Just mirroring the existing company?
Yes, they would be very similar to the facilities that this company has now.
Okay, thank you.
Thank you so much.
You guys